Hello everybody, welcome to chapter 13. You are in luck. This is going to be a very short chapter for you because the book bogs us down with some details that we don't necessarily need to know. For example, the color of this substance reacting with that one in this process. It is not as important. What is very important in this chapter is that you know the trends. That the different groups or families have in the periodic table. So we'll go over that, and we'll also go over the kind of elements that we have, such as metals, non-metals, metalloids, and how they all work together and what are the different properties they have. But it will not be too long of a chapter, and just reviewing the trends of the periodic table. So let's start with that. Here's our beauty periodic table. You should all have a copy of it next to you as we do these exercises. So let's review these 4 trends, okay, and then we'll also talk about this one. But let's review and see, how does electronegativity change in the periodic table? How does the ionization energy change? How does the electron affinity change? And how do the radii change of the individual atoms in the periodic table? And furthermore, why they are all really connected. So why this is all very much connected. So when you learn ionization energy, it makes sense in the light of electronegativity, for example. Okay? Same thing with the radii, same thing with electron affinity. All right, so let's start with electronegativity, the most kind of central piece of it all. So electronegativity of an atom or an element is the ability with which its nucleus pulls on the electrons. Okay? So it's the strength of the nucleus to pull on the electrons. Let's look at how it looks like at the periodic table. Electronegativity increases this way, okay? And it increases up. That means, what are going to be some of the most electronegative elements? Well, it's actually Mr. Fluorine right over here, the most electronegative one, okay? Why does it increase this way and up? Because what is the dream that most elements that we talk about, what is their dream? What dream do they have? They have a dream of having how many valence electrons? 8 valence electrons, right? So the way I like to explain it to students, the way you can always remember it is, think of it as, very, very kind of poor people with only 1 or 2 valence electrons, okay? And then think of very rich people, the noble gases, the kings and queens. They are living the dream. They have the 8 valence electrons, that perfect octet. But their neighbors, the ones that live only a street down, they're the halogens. They